In the previous segment, I talked about discovery. So that was the process by which service clients discovered an available service instance to route a request to. Now, and a key part of that process involved service instances registering with a service registry. There's an interesting issue around registration, namely, who does it? And there's a couple of different approaches that you can use. So one pattern is the self-registration pattern, where a service instance is responsible for registering itself with the service registry. The other option is for a third party, something that's outside of the service instance, to be responsible for registering that service instance with the registry. There's various issues that you need to consider when you're thinking about service registration. So service instances need to be registered with the service registry on startup. They need to be unregistered when the service shuts down. And if they crash, they also need to be unregistered as well. And also, if service instances are running, but they're not actually capable of handling requests, then they're somewhat useless and they need to be unregistered as well. So there's a couple of different patterns that you can use. So one of which is self-registration. That's where the service instance is responsible for registering itself with the service registry. So service registry, it's the database of available service instances, and it will typically have an API for registration. So normally what will happen is a service instance starts up, registers itself, periodically sends some kind of heartbeat saying, "I'm still here," which sort of implies availability. And then when it shuts down, it can unregister. And if it crashes, then it's going to stop sending heartbeats and its registration will time out and be removed from the database. So there are various examples of this approach. So one is the Netflix Eureka Java client. A Java service, when it starts up, will register itself with the Eureka server. It can also register a health check that the registry can use to check that the service instance is actually still available. In the Zookeeper world, Zookeeper's much lower level, but there's a recipe for using Zookeeper as a service registry. And what that translates into is a service instance ends up creating an ephemeral child of a well-known znode, if you're familiar with Zookeeper. So a couple of common examples. One benefit of self-registration is that it's really simple. The service takes responsibility for doing the registration. There's no other extra components that have to take over. But a big downside is the service has to know about the registry. And what's worse is if you're using multiple languages, then you have to implement the registration logic in each one of those languages. And so that can be burdensome to do that. So, on the one hand, it's simple, but if you're writing services in a mixture of languages, then it's sort of a bit of a pain in order to implement the same logic over and over again, once in Java, once in JavaScript, and yet again in Golang, and so on. So for that reason, you might want to think about the third-party registration pattern. And the idea there is that some other service or some other system component is responsible for registering a service instance with the registry. So this component somehow detects that the service instance is started up, registers it with the service registry, periodically does a health check, and then can send heartbeats into the service registry. The service knows nothing about the service registry at this point. The registrar is interacting with it. and the registrar can unregister the service instance when either it fails the health check or the service instance goes away. So there are a few different examples of this, actually quite a few different examples. So like in the AWS world, auto-scaling groups can automatically register, deregister instances with an elastic load balancer, which sort of acts as an implicit service registry. In the Docker space, there's a project registrator that looks at that monitors the available Docker containers and can register them with a service registry. Joyent have a container buddy project that basically actually, when you start a Docker container, the process that runs is actually the container buddy, which then starts your service, which could be a JVM or a Go process or whatever. And then the container buddy is responsible for registering that service with a service registry like console or etc.d, or so on. Mesos and Marathon have this feature built in, and then Netflix has this sidecar application, kind of like Container Buddy. It runs alongside your service instance that can deal with the registration. So as this name suggests, it's running alongside. So, a bunch of different examples there. So there's various benefits. One really good benefit is that it makes the service simpler. The service doesn't have to know about the service registry. The registrar is responsible for doing the registration and the deregistration and running health checks and so on. Plus, some environments just give you this for free. So the downside is that if the environment doesn't give it to you for free, then it's yet another component that has to be set up and operated and maintained and has to be highly available. So it adds to the overall complexity of your system, which can be unfortunate. So in summary, a couple of different ways of doing registration. Service instances can do it themselves, or you can have a third party do it on your behalf. And there's various trade-offs with each one of these approaches.